Science for the Society. Science Café. Science engagement is an overarching term that includes all aspects of public engagement with science. Science communication, science literacy, and science outreach and awareness. Simply, science is the systematic knowledge generated in all societies, in universities and research institutes. For developing countries, science could solve all problems. And that is why Science Café and science clubs are necessary, together with scientific institutions in developing countries to spread awareness based on science, which could be important steps toward meeting the society's needs. Historically, science is, and always, directed towards solving problems, especially those important for society's needs. The importance of science in the world is now much clearer in the time of COVID-19. In this sense, we try to put academics together with early career researchers to introduce scientific way of thinking to apply science in our daily life. We started at National Research Center, then Ain Shams University, then National Institute of Astronomy and Geological Research. There are also many other attempts for Science Café in Egypt. The following are overview for our activities. Science Café is an event that takes place in casual settings. It is for proposing scientific ideas and is open for everyone. It is an attempt to cross the borders between academics and public in order to spread science for the society. We believe that science is for all, and science could solve all problems not only in the modern countries but of course in the developing countries, even more than those of modern standards of life. During this conference, as well as each conference, we launch Science Café for school students and public to share with them some of our ideas, and to simplify some of our scientific missions that we already did in our labs. Also, it is a good opportunity for public to engage in discussions with scientists about a particular topic. Finally, it is supporting our efforts to build the society based on scientific knowledge. Everyone can follow our activities through the following links. Molecular Modeling and Molecular Spectroscopy Group at National Research Center. Science Café as an activity was started in National Research Center at the Group of Molecular Modeling and Molecular Spectroscopy at Spectroscopy Department Physics Division in Egypt. In addition to providing professional technical consultations in molecular spectroscopy and designing molecular models for wide areas of applications, the unit as society engagement also provides training, workshop offline and online specially for early career researchers. The overall aim is to explore materials to functionalize materials from many applications which enable the members of the unit to have some projects and awards in many areas in both national and international scale. Moreover, the unit is now collaborating with several research groups and institutes inside and outside Egypt. This presentation is going to illustrate the most recent activities of the Molecular Modeling and Molecular Spectroscopy Group at the National Research Center. The group members of the unit are also engaged in multiple and diverse activities directed towards society engagement inside and outside the National Research Center. It is worth to mention that in the middle of 2023 the unit became part of the Center for Excellence for Advanced Science at the National Research Center. 3D printing technology has also been introduced to the activities of the unit to serve in the applications of material sciences and biomaterials. And we have been recently granted an STDF grant titled Eco-Friendly Cost-Effective Microsphere for multiple applications to produce cost-effective and easy handling devices for microsphere production based on 3D printing for different applications. Our unit is willing for collaboration at and outside National Research Center in both national and international scale. Molecular Modeling Group at Faculty of Women for Art Science and Education Ain Shams University. We started early as a collaborator with Molecular Modeling and Molecular Spectroscopy Unit at the National Research Center. Then after granted an STDF project, the unit was launched at the Physics Department Faculty of Women for Art Science and Education Ain Shams University. Some workshops were launched in the university and we hosted the first spectroscopy winter school in December 2018. Moreover, we are among the hosting intuitions for the International Conference on Molecular Modeling and Spectroscopy. Additionally, we continue launching seminars and workshops both offline and online. We investigate materials based on their unique electronic properties investigated by molecular modeling. We also have much international as well as national collaboration. As part of our mission, we train students on the recent developments in smart and nanoscale materials. We do believe that Science Café is an important event for early career researchers, thus we are proud that our efforts are part of Science Café efforts. Also, we are going to participate in the activities of the Nano Club with Group of Nanotechnology Research Center at the British University in Egypt. The unit is involved in different international collaborations such as the Academy of Scientific Research and Technology and Joint Institute of Nuclear Research bilateral project, titled Molecular Modeling and Experimental Neutron Scattering Studies of Interactions of the Condensed Matter and Biological Lipid Membrane Systems, directed towards the design and implementation of cost-effective biosensors in collaboration with the Molecular Modeling and Molecular Spectroscopy Group at National Research Center. Nano-NRIAC Unit at Solar and Space Research Department National Research Institute of Astronomy and Geophysics was established as a new branch of nanotechnology. This new branch is specialized in the preparation of nanomaterials for aerospace applications. The unit cooperates with many universities and research centers specialized in the field of nanotechnology. Recently, the lab is involved in the activities of Science Café as well as Nano Club as part of our responsibilities toward the society. The unit expertise focuses on using nanotechnology to produce materials with unique properties in order to overcome material challenges that spacecraft and satellites face in the space environment. These modifications allow the materials to be utilized in a variety of space applications. NRIAC is considered among the most distinguished research facilities in Egypt concerned with the preservation of cultural heritage. In this sense, the unit is engaged in a number of international collaborations such as the recently accepted Academy of Scientific Research and Technology and the Joint Institute of Nuclear Research bilateral project for the preservation of cultural heritage in collaboration with the Molecular Modeling and Molecular Spectroscopy Group at the National Research Center. The Academy of Scientific Research and Technology. The Academy of Scientific Research and Technology is considered a public authority with an independent status and affiliated to the Ministry of Scientific Research, with headquarters in Cairo, acting as its executive arm for the design and implementation of national programs and roadmaps. The Academy of Scientific Research and Technology is the national house of expertise and national think tank in the field of science. Technology and innovation. It is the national umbrella for the planning of scientific research activities in Egypt. It includes the national committees of 20 international scientific unions and has 15 specialized councils for various branches of scientific activities. The Academy of Scientific Research and Technology is also a national coordinating body and funding organization for research and innovation in Egypt. It hosts sectorial councils on medical research, ethics and drug research. It is also host to strategic committees such as the National Pharmacology Committee and to key departments such as the Patent Office and the National Innovation and Invention Development Agency. With more than 7 regional centers and a broad geographical coverage in Egypt, the Academy of Scientific Research and Technology plays a wide range of roles and carries out many activities in preparedness and response to infectious diseases. The Council suggests appropriate research projects to be conducted with the Academy of Scientific Research and Technology to solve some of the problems of these sectors and to meet the national development programs. The Academy of Scientific Research and Technology provides consultations to the government and decision makers on issues related to science and technology in Egypt and around the world. The Academy of Scientific Research and Technology acts as the main technical branch of the Egyptian Knowledge Bank, which is the world's largest digital library and online repository, providing massive scientific resources exclusively to Egyptians while promoting open science and research integrity. The Academy of Scientific Research and Technology is a main publisher in the region and coordinates a large number of journals and local periodicals. The Academy of Scientific Research and Technology is also committed to supporting collaborative research in Africa and the Mediterranean area. The synchrotron light source. Light is a fundamental phenomenon which originates from the sun. While there are some attempts for scientists to have artificial light source, among the man-made activity to have light source there is a so-called synchrotron, which will be defined and highlights will be made on its important applications. Synchrotron light, also referred to as synchrotron radiation, is radiation that is emitted when charged particles moving at speeds near the speed of light are forced to change direction by a magnetic field. It is the brightest artificial source of X-rays, allowing for the detailed study of molecular structures. When synchrotrons were first developed, their primary purpose was to accelerate particles for the study of the nucleus. Today, there are almost 60 synchrotron light sources around the world dedicated to exploiting the special qualities, which allow it to be used across a wide range of applications, from condensed matter physics to structural biology, environmental science and cultural heritage. The synchrotron light for experimental science and applications in the Middle East. Sesame. The synchrotron light for experimental science and applications in the Middle East is an independent laboratory located in Ain in the Balka Governorate of Jordan. Created under the auspices of UNESCO on May 30, 2002. Its central facilities aimed at promoting peace between Middle Eastern countries. Jordan was chosen as the location for the laboratory, as it was then the only country that maintained diplomatic relations with all the other founding members: Bahrain, Cyprus, Egypt, Iran, Israel, Pakistan, the Palestinian Authority, and Turkey. It is the only synchrotron radiation facility in the Middle East and is one of around 60 in the world. In a synchrotron, bunches of charged particles, electrons, circulate at nearly the speed of light for several hours inside a tube under vacuum. As magnets surrounding the tube bend their trajectories, the electrons emit synchrotron light, with wavelengths that range from infrared radiation to X-rays. The emitted light is collected by different beamlines connected to the storage ring. Beamlines contain the optical elements that select and focus certain wavelengths of the synchrotron light on materials that scientists wish to study, as well as the setup for controlling the sample's environment and for data collection. Each beamline is designed to produce light with characteristics that are suited for a specific type of research. Synchrotron light beam lines provide one of the most powerful and advanced tools available in modern science for research, covering a wide range of disciplines ranging from materials science and engineering to medicine, cultural heritage, healthcare and the environment, as well as fundamental understanding in physics and chemistry. They are also the physical area within the experimental hall where the scientists visiting Sesame, referred to as users, carry out their experiments. They are the workplace where the users, often with diverse cultural, political and religious backgrounds, interact on scientific issues and through this build cross-border scientific collaboration, dialogue and understanding. Beamlines facilities available at Sesame. Sesame will be exploited in up to 20 or more experiments operating simultaneously on independent beamlines, which will focus the synchrotron light on samples of materials. In the first phase, there will be 8 beamlines. These beamlines have been selected on the basis of input from 5 scientific workshops and the early users meetings in which several hundred Middle East scientists participated, on 70 proposals received, and joint meetings of the Scientific Advisory Committee of Sesame and the now defunct Beamlines Advisory Committee of Sesame. These beamlines including Infrared Spectromicroscopy Beamline. This beamline started hosting users on November 4, 2018. X-ray Absorption Fine Structure X-ray Fluorescence Spectroscopy Beamline. This beamline started hosting users on July 17, 2018. Materials Science X-ray Powder Diffraction Beamline. This beamline started hosting users on December 17, 2020. BEATS, Beamline for Tomography at Sesame. This beamline came into operation in 2023. HESABE, Helmholtz Sesame Beamline. This soft X-ray beamline came into operation in 2023. TESPS, Turkish Soft X-ray Photoelectron Spectroscopy, Beamline. This beamline is being constructed by a Turkish consortium led by TENMAK, Turkish Energy, Nuclear and Mineral Research Agency. It is the first beamline at Sesame to be designed and built by the national community of one of Sesame's members, Turkey. Macromolecular crystallography. This beamline is presently being designed, its construction is still to start. Small angle and wide angle X-ray scattering beamline. Plans for this beamline are yet to start. How to participate in Sesame activities. The first step toward participation in the Sesame activities is to log into the Sesame web page, then register your name as Sesame user. The web page can be found at There is also Sesame User Office, which is termed SUO. You can find some details about it on the web page. Joint Institute for Nuclear Research in the past. The Joint Institute for Nuclear Research was established on the basis of an agreement signed on March 26, 1956, in Moscow by representatives of the governments of the 11 founding countries, with a view to combining their scientific and material potential. The Union of Soviet Socialist Republics contributed 50%. The People's Republic of China 20%. On February 1, 1957, Joint Institute for Nuclear Research was registered by the United Nations. The institute is located in Dubna, 120 kilometers north of Moscow. At the time of the creation of the Joint Institute for Nuclear Research, the Institute of Nuclear Problems of the Academy of Sciences of the Union of Soviet Socialist Republics already existed at the site of the future Dubna since the late 1940s. and it launched a program of fundamental and applied research at the synchrocyclotron. The Electrophysics Laboratory of the Academy of Sciences of the Union of Soviet Socialist Republics was established, and under the guidance of academician Vladimir Veixler, work began to create a new accelerator, a proton synchrophasotron, with a record energy of 10 GeV at that time. By the mid-1950s, there was a worldwide consensus that nuclear science should be accessible and that only broad cooperation could ensure the progressive development of this research, as well as the peaceful use of atomic energy. Thus in 1954 CERN was established. At about the same time, the countries that belonged to the socialist community decided to establish a joint institute for nuclear research on the basis of the Institute of Nuclear Problems. Joint Institute for Nuclear Research, JINR, now. JINR has at present 16 member states: Armenia, Azerbaijan, Belarus, Bulgaria, Cuba, Arab Republic of Egypt, Georgia, Kazakhstan, DP Republic of Korea, Moldova, Mongolia, Romania, Russia, Slovakia, Uzbekistan, and Vietnam. Participation of Germany, Hungary, Italy, the Republic of South Africa and Serbia in JINR activities is based on bilateral agreements signed on the governmental level. The supreme governing body of JINR is the Committee of Plenipotentiaries of the governments of all 16 member states. According to its charter, the Institute exercises its activities on the principles of openness to all interested states for their participation and equal mutually beneficial cooperation. On November 22, 2021, at the session of the Committee of Plenipotentiary Representatives of the Governments of the Joint Institute for Nuclear Research member states held in Bulgaria, a declaration was adopted to highlight the value of international scientific and technological integration in solving the tasks of strengthening peace, mutual understanding, and socio-economic progress of all the countries. More details can be found at the website. Arab Republic of Egypt, Joint Institute for Nuclear Research Cooperation. Scientific contacts between Arab Republic of Egypt and Joint Institute for Nuclear Research were established at the end of 1960s, beginning of the 1970s. When Ahmed El-Nagi and Mohammed Sharif began to take part in research using photoemulsion techniques at the Laboratory of High Energies. Joint Institute for Nuclear Research, Arab Republic of Egypt started on March 3, 2009 when the agreement between the Joint Institute for Nuclear Research and the Ministry of Higher Education and Scientific Research of Arab Republic of Egypt was signed. Since 2009, the practice for young specialists from Arab Republic of Egypt has been held at Joint Institute for Nuclear Research. During these schools the participants have lectures and practical training at Joint Institute for Nuclear Research laboratories. The knowledge and experience gained at these schools allow their participants to continue their studies in Egypt and give them an opportunity to be involved in the joint research projects. On November 22, 2021, at the session of the Committee of Plenipotentiaries of the Governments of the Joint Institute for Nuclear Research member states, Egypt became a full-fledged Joint Institute for Nuclear Research member state. Laboratories available at JINR. The main areas of theoretical and experimental research at JINR are particle physics, nuclear physics, and condensed matter physics. The research program of JINR is aimed at obtaining highly significant results of principal scientific value. The experimental base of JINR gives the opportunities to conduct not only advanced fundamental research but also applied studies in the field of condensed matter physics, biology, medicine, material sciences, geophysics, engineering diagnostics that are focused at research of structure and properties of nanosystems and new materials, biological objects, at elaboration and development of new electronic, bio and information technologies. JINR comprises 7 laboratories, Weixler and Baldwin Laboratory of High Energy Physics, Jelepov Laboratory of Nuclear Problems, Bogolyubov Laboratory of Theoretical Physics, Frank Laboratory of Neutron Physics, Flerov Laboratory of Nuclear Reactions, Meshcheryakov Laboratory of Information Technologies, Laboratory of Radiation Biology. Each laboratory being comparable with a large institute in the scale and scope of investigations performed. The institute employs about 4,500 people, including more than 1,200 scientists, among whom there are full members and corresponding members of National Academies of Sciences, more than 260 doctors of science and 560 candidates of science and about 2,000 engineers and technicians. The European Organization for Nuclear Research, CERN. At an intergovernmental meeting of UNESCO in Paris in December 1951, the first resolution concerning the establishment of a European Council for Nuclear Research, in French Conseil Européen pour la Recherche Nucléaire, was adopted. 2 months later, an agreement was signed establishing the Provisional Council. The acronym CERN was born. This agreement gave the Council 18 months to produce the formal CERN Convention. Today, our understanding of matter goes much deeper than the nucleus, and CERN's main area of research is particle physics. Because of this, the laboratory operated by CERN is often referred to as the European Laboratory for Particle Physics. In June 1953, the final draft of the CERN Convention was agreed upon and signed by 12 new member states. It laid out the ways member states would contribute to CERN's budget, as well as early indications of CERN's ethos and organization, from adopting a policy of open access, to CERN's internal structure being divided into directorates. Today, CERN's size means that these directorates are subdivided into departments and then, in turn, groups and sections. Signing the convention led to a huge swell in momentum, and very quickly staff were hired, architects were brought in and plans were drawn up. In July 1955, Felix Bloch, CERN's Director General, laid the first foundation stone. Since then, CERN has more than fulfilled the early plans of those few optimistic scientists who dreamt of creating an international laboratory to make great strides in fundamental research and stretch the limits of our technology and imaginations. More details can be found at the website. Main activities of CERN. CERN's main focus is particle physics, the study of the fundamental constituents of matter, but the physics program at the laboratory is much broader, ranging from nuclear to high-energy physics, from studies of antimatter to the possible effects of cosmic rays on clouds. CERN hosts a gigantic complex of particle accelerators. An accelerator propels charged particles, such as protons or electrons, at high speeds, close to the speed of light. They are then smashed either onto a target or against other particles circulating in the opposite direction. By studying these collisions, physicists are able to probe the world of the infinitely small. A range of experiments at CERN investigate physics from cosmic rays to supersymmetry. CERN is home to a wide range of experiments. Scientists from institutes all over the world form experimental collaborations to carry out a diverse research program, ensuring that CERN covers a wealth of topics in physics, from the Standard Model to supersymmetry and from exotic isotopes to cosmic rays. Several collaborations run experiments using the Large Hadron Collider, LHC, the most powerful accelerator in the world. In addition, fixed target experiments, antimatter experiments, and experimental facilities make use of the LHC injector chain.